Hello everyone. Today we will be talking about periodic trends. And there are different trends, so let's get to it. The first one is atomic radius. And all it is, it's the size of an atom, right? Now, the size is dependent on the number of shells. So the less shells an element has, the smaller the radius. Now, if two elements have the same number of shells, then the one with more protons will have a smaller radius. And to do this, let's look at this periodic table. This periodic table shows a decrease of size. So the higher we are on a group, the smaller it is, and the more to the right we are, the smaller it is. So let's compare lithium and potassium, right? Lithium is higher than potassium, so it is smaller. And to do this, we talk about the shielding effect. The shielding effect just basically says that because an element has more shells, it has more electrons, and therefore there is less attraction between the nucleus and the valence electrons. And you can also see it here when I drew the shells of an element, right? Notice how lithium is much smaller. It has less shells, therefore it is smaller. But now when I talk about a period, the radius decreases to the right. That was established, and you can go back to the periodic table. But for that, we use ZeV as our argument, or the effective nuclear charge. So if two elements have the same number of shells, then the element with more protons is smaller because there is more attraction between the nucleus and the valence electron. So we're talking about carbon and fluorine. Their valence electrons are the same distance from the nucleus. And fluorine has more protons. So there's more attraction between fluorine and its valence electrons than carbon and its valence electrons, making carbon the bigger element. That's the first trend. The second one is ionization energy. All it is the energy required to remove an electron. So if we look at this periodic table, the energy required to remove an electron is higher as you go up a group, and it's higher as you go to the right. Meaning that lithium has a higher ionization energy than cesium. Lithium has a smaller ionization energy than fluorine. Correct? Now, to explain this, we could say that because we are removing a valence electron, then the closer those electrons are to the nucleus, the harder it is to remove them, right? Remember, there is more attraction between the electrons and the nucleus in a smaller element, and therefore it becomes harder to remove those electrons. Now, elements could have multiple ionization energies because they have multiple electrons. So for example, iron has 26 electrons, so it can have 26 ionization energies. Remember that every element wants to behave like a noble gas. It wants to have an electron configuration like a noble gas. So once the element has that configuration, it becomes extremely hard to remove another electron. For example, let's take a look at sodium ion and magnesium ion. If we were to have their neutral atoms, we say that it's harder to remove an electron in magnesium than sodium. But because they are not the ions, sodium, as a +1 ion, has a configuration like neon, meaning it is already highly stable. But magnesium, if it's just a +1, it has a configuration like sodium, and it wants to lose another one. So based on that, we say that sodium, because the sodium ion, because it is highly stable, it is a lot harder to remove another electron there than it is in magnesium, right? Because magnesium still has to lose one more to become highly stable. And that's it for ionization energy. The other ones I want to talk about is electron affinity and electronegativity. So electron affinity is a change in energy that occurs when an element gains an electron. And electronegativity is the tendency of an element to gain an electron. So for both of those, this periodic table shows how the trend goes. So there's an increase in both of them as you go up, and then increase as you go to the right. Now for electronegativity, we do not include the noble gases because they don't want to gain an electron. They want to be just like they are. So if we remove the noble gases for that trend, the most electronegative element is fluorine, right? It is the one at the highest and to the right, and the most to the right. Not counting the noble gases because they don't get included in this trend. So fluorine is the most electronegative element. And that's it for the trends. I hope this helps, and thanks for watching.